Hi, this is Chris, and we are taking a look at question 12 in Digital SAT Practice Test 1, Math Module 1. So here it says, a rectangle has a length of x units and a width of x minus 15 units. If the rectangle has an area of 76 square units, what is the value of x? And what we're going to do here is, since they give you a length and a width, then we just have to know how to find area of a rectangle. And the area of a rectangle is length times width, which means that x times x minus 15 equals 76. Now there's two ways to approach it from here. What you could do is solve this out and convert this into a quadratic. So I'm going to put that over here. And that would be x squared minus 15x equals 76. If you bring over the 76, you get x squared minus 15x minus 76 equals 0. And you could go to factor this out and try to figure out what factors of 76 would somehow add or subtract to get to 15. And that would be x minus 19 and x plus 4. And then your positive solution here would be 19, because negative 4 won't work. You can't have a length of a negative value. And since they say the length is x, then that has to be the positive value, which is 19. So you can do that, but admittedly, this is not the easiest thing to factor out. 19 times 4 equaling 76 is maybe something that I'd say a lot of test takers aren't going to know off the top of their head, so this is an option. And we'll keep this here because those are pretty helpful skills to know. But if you're able to get this expression, we can also go this way and dive right into these answer choices and say, hey, which of these answer choices can I plug in for x and get 76? And that's a little bit easier to do, because if you plug in a 4, you'd realize you'd get a negative number. So right away you can tell that that one's not going to work for you. And if you plug in 19 next, and you do 19 times 4, and you get 76, then you're done. So this question's actually pretty fast for us to plug in. We still have to understand this initial relationship though, either way. So definitely make sure you are comfortable with your factoring, because sometimes you will have to factor a quadratic, but here, using your answer choices to your advantage to plug in these values is going to end up saving you quite a bit of time. Up next, let's take a look at question 13. So for this one, they give us this table, and it shows time in years and total amount in dollars. And it says Rosa opened a savings account at a bank. The table shows the exponential relationship between the time t in years since Rosa opened the account and the total amount n in dollars in the account. If Rosa made no additional deposits or withdrawals, which of the following equations best represents the relationship between t and n? So your total here is going to be whatever that original amount that you started with. And then since it's an increase, right, because here we're earning some type of interest on the account, but we can see that these amounts are going up. So as you go from 604 to 606.42 to 608.84, we can see that there's an increase. So here, since we have an increase, we want to figure out what that increase will represent. And since it's increasing, it's going to be 1 plus whatever that percent increase is as a decimal. And you're going to be multiplying times that amount of increase. Basically, year over year, you're going to see that that increase is going to be multiplied times that amount from one year to the next, to the next, to the next, which means that it's going to be to the t as an exponent. And luckily, we don't have to worry about the t part of it, because every answer choice has something to the t power. So really, all we have to understand here is to figure out the kind of increase. Our structure should be original amount, which we can see at the very beginning when time is 0. That's your original amount. That's your starting value. So that would be 604 times 1 plus something. And already, once we're here, we can finish it out, but you can tell that answer choice C is the only one that's going to match that structure. And so we would get answer choice C for 13, and we don't have to take the time to actually do that percent increase. So here the 0.004 and the exponent of t, we can really just take for granted, because as long as we know that this has to start with your total is equal to the original times some sort of percent change, then it's got to be C, and we're done right then and there. So again, taking a look at these questions in a different light, not necessarily thinking about everything purely mathematically, but thinking about how can we arrive at the correct answer choice most efficiently, can really help us think like a standardized test taker. All right, for question 14, we're going to have another opportunity to use that same line of thinking. Here, they want to know how many points do the graphs of these equations. We have y equals x plus 20 and y equals 8x. And we could probably graph those, but if you happen to notice that these are linear equations, so both are in the form of y equals mx plus b. And since we have slope-intercept form, as long as the slopes are different, this one has a slope of 1, this one has a slope of 8, then that means that those two lines will intersect somewhere, and because it's linear, that point of intersection will be just 1 point, and we're done. So we might have to get a little more technical with how to graph it if they had a quadratic, or if they had a cubic function, and we're looking at where that potentially intersects with a linear function. But here, if we have two lines, and they have different slopes, then they're going to intersect at just 1 point, always, always, always. Now, if they had the same slopes, it's possible that they could have no points of intersection if they had been parallel. Or if they had the same slope and the same y-intercept, then it might be one line just right on top of the other. They might actually represent the same line, which means you would have an infinite number of points of intersection. But here, since they have different slopes, it can only be this 1 point of intersection, and we can confidently pick B and move on. So let's do just that, and here we're going to take a look at 15. And for number 15, it says at a school fair, students can win colored tokens that are worth a different number of points depending on the color. One student won G green tokens and R red tokens worth a total of 380 points. The given equation represents this situation. How many more points is a red token worth than a green token? So if there are red tokens, then that means that to figure out your points, you're multiplying each red token times 45, which means that the red ones are worth 45 points. And the green ones, correspondingly, are only worth 5 points for each one. So you'd have to multiply by however many tokens you have, but they just want to know how many more points is a red token, one red token, compared to one green, and that's going to be 45 minus 5, which will be 40 more points. So that equation that we see there is simply telling us that there are 5 points for each green token, 45 points for each red token, adding up to our total of 380 points, and that allows us to find the difference in point value for red versus green. So you'll go ahead and enter in 40 and move on to question 16, which we will do in our next video. So stay tuned. Thanks for watching.